When you look at my webpage on Canvas, we have covered 3 modules. Last one we covered was module 3, chapter 5 and 6, and now we are moving on to module 4, okay, covering chapter 7 and 8. That will be the last module that we're going to cover. So I'm going to click on that module and show you the resources you have there. If you look at module 4, okay, that went in somewhere. Module 4. We're going to cover chapter 7, which is on energy storage, mainly batteries and battery powered vehicles, anything to do with batteries, energy storage. And the chapter 8, we're going to cover about water. Water is a good solvent for many things. Water is essential for life. We're going to look at different aspects of water, how we purify water, groundwater, potable water, etc. So let's finish chapter 7 and go there. So like in module 3, you have PowerPoints. I'm going to add the video, Zoom class video after we're done today. So you can go through this and get ready for doing the quiz 7. Quiz chapter 7. Quiz is there. I'm not sure where that is. I will make sure that it is there. Okay. Right now I cannot see it. Probably I have to go back and make it visible. All right. I'm going to start with chapter 7. I'm going to go to PowerPoint slide presentation. All right. Can you see my first page of PowerPoint presentation? Energy storage, chapter 7. Can you see it? I'm just checking whether if you can see it before I start talking.
Yeah, I can see it.
Okay. Let me go start from the beginning. All right. We're going to have a test on November 24th on chapter 7 and 8. So first finish the chapter 7 today and then move on to chapter 8 on water. The topic of chapter 7 is energy storage. Energy storage is mainly based on batteries. We store energy as electrical energy mainly for electronic devices, lights, etc. So batteries are the storage devices. What is a battery and how does it work? In a battery, there's a chemical reaction which we call redox reaction, reduction oxidation reaction, that provide electron flow for battery power. So there are many redox reactions that could be converted into a battery. So we're going to mainly say battery is a electrochemical reaction. Electrons are produced in chemical reaction. We call it reduction oxidation reaction, redox reaction. Now the current is produced in batteries. Batteries have a voltage. You hear about voltage in a battery. You can measure voltage with the meter or voltage meter. I have a digital one. I can check my battery, whether it's still working or not. In a battery, voltage is related to resistance, which we measure in ohms, and the current. There's an equation called V is equal to IR. We are going to look into that. That's the Ohm's law. So we're going to look into Ohm's law. Now batteries are everywhere. In your flashlight, in your car, in your computer, in your cell phone, batteries are everywhere. Cameras, etc. Face makers. So we need to know how we operate them and what kind of batteries are available. This is sensitive. Now some batteries are rechargeable. Almost we can use for many charging cycles. So battery could be rechargeable. Some of are not rechargeable. We're going to see the difference in those two batteries, non-rechargeable, rechargeable. Let me hold on this 7.5. One of the batteries that we use in cars, vehicles, is lead acid battery. Most of you are familiar with lead acid batteries. They are rechargeable. They have sulfuric acid and lead oxide. Terminals where we draw the current to start the engine, ignite the engine. Some vehicles are powered by electricity. We're going to look into hybrid vehicles and what kind of batteries are used in Toyota Prius and other vehicles. Now, storage of electricity is a big deal. One of the ways to store electric charge, which can be used, is capacitors. And there are supercapacitors. And batteries use chemical energy as a storage that could draw electric current. Like supercapacitors also can draw electric current. We're going to compare these things, capacitors, capacitors and batteries in following chapters. Higher miles per gallon with less emission are hallmark of gasoline electric hybrid vehicles. They have less emissions because batteries in hybrid vehicles don't produce emissions. Therefore, hybrid vehicles have less emission and higher miles per gallon. There's another development recently. The cars are made by a battery called fuel cell. There are different kind of battery. We're going to look into fuel cell batteries. The future of the energy storage in cars and other places going to take over by fuel cells. We're going to look into that. Fuel cells use hydrogen. So we need to know hydrogen economy, how we make hydrogen, how we can store it, and things related to fuel cells using hydrogen as a fuel. Now, if your battery is dead, what you do with it? So sometimes you recycle it. Sometimes you recharge it and recover. If nothing else could do with the battery, you need to recycle it. So we're going to look into that aspect of storage devices, recycling. Now, there are a lot of batteries in this picture. They're used as energy storage. Some of them are small, some of them are big, some of them are used in cameras, some of them are used in flashlights, etc. So what are the main types of batteries and how do they work? The main type of batteries are nickel cadmium batteries, alkaline batteries, nickel hydride batteries used in hybrid vehicles, lithium ion batteries, and lithium polymeric lithium batteries. They are used in, lithium batteries are used in cameras and cell phones and laptops. We're going to look into that, how they produce a current. What are the difference between galvanic and electrolytic cells? Galvanic cells are batteries, which has a reduction oxidation reaction, a chemical reaction taking place, producing a flow of electrons that could be used to power up a device, a bulb, etc. Electrolytic cell is when you pass electric current through a redox reaction. Normally, redox reaction produce in the way galvanic cell is. It produces electric current. Galvanic cell produce electric current. The reverse of that, when you provide an electric current to a redox reaction, it also breaks up the chemicals into different species. That's the electrolytic cell. For example, you can break up water with the electricity to hydrogen and oxygen. That's the electrolytic cells, where electrons are used to break up the chemicals. Galvanic cell is chemicals are used to produce an electric current. The batteries are recycled, not to a great extent right now. We throw them out in garbage cans. But eventually, as we run out of our resources, the batteries will be recycled. They may contain certain metals that are expensive. So in the future, more recycling is going to go in. What is a hybrid vehicle? Hybrid vehicle is a vehicle that uses a battery and gasoline. Together, they produce they can operate a vehicle at higher miles per gallon. You understand what is a hybrid vehicle. Hybrid is using both a battery and a gasoline. We're going to look into them. What are the difference between supercapacitors and batteries? Batteries, we already talked about, has chemicals, stored chemical energy, which could be converted to electricity. Supercapacitors are related to capacitor. A charge plate with a dielectric is called a capacitor. In electronic circuits, we have capacitors. Supercapacitors are when you put in between positive and negative charge plates of a capacitor extra ions, cations and anions. They have more electricity, electric charge. They can be used to power up certain circuits, certain devices. So supercapacitors and batteries do the same thing, but their origin of electricity is different. Batteries, electricity comes from chemical reactions. Supercapacitors are stored ions between two charge plates. That stored charge particles could be used to create an electric current. So we're going to look into fuel cells. You really don't, I cannot explain it right now. The cars could be fueled using fuel cells rather than gasoline. So it's more efficient. Future of the motor vehicles are in the development is mainly going to be based on fuel cells. Now, let's reflect on some of that. There's a battery. That battery is a car battery. Role of batteries in your everyday life. We already talked about it. Cars, computers, any device, lighting systems. So we use batteries, pacemakers, medical devices. So you can watch the video. There's a link in the bottom. So how your life would change without batteries. So without batteries, our life will be different. So there are many places, many things that we need a battery. So even in solar cells, using solar cells, we use batteries to store extra energy, then use the sun's energy stored as a voltage in the batteries to use during the dark or night time. List all your daily activities that involve use of batteries, include type of battery used for each of these activities. So you're going to know what kind of batteries are there. Then we're going to tell you what are they used for, what kind of activities they provide. Then batteries are different. It depends on the chemical reaction. So we're going to look at it, how many types of chemical reactions commonly used batteries use. There are different chemical reactions. Some batteries could be recharged, some cannot be. The rechargeable batteries are called secondary batteries, secondary. You can recharge. Primary batteries are the ones that cannot be recharged. Their reaction is just a regular reaction. A reactants go to product, you cannot reverse it. But in a rechargeable battery, chemical reaction is reversible. If you pass a current through the discharge battery, you create the chemicals of the battery, recreate, so you can reuse it. Number of possible charge-discharge cycle until they are no longer able to. Sometimes things get worse after so many cycles. So we're going to talk about that. Okay, let's look at this. There's a reaction here. There's a dashed line. There are two reactions. Copper losing copper 2 plus on the left top, copper 2 plus gaining an electron to produce copper. The gaining electron is a reduction. We're going to talk about that more. On the right side, zinc loses the electron, 2 electrons, produced zinc 2 plus. Zinc loses electrons, zinc undergo oxidation. Copper 2 plus undergo reduction. Now, if you have a redox reaction like this, normally if you mix up these chemicals in one pot, it's going to transfer electron directly from copper 2 plus to zinc, copper 2 plus to zinc 2 plus. Okay, so copper going to become copper 2 plus going to become copper, zinc going to turn into zinc 2 plus. But if you separate them out in a galvanic cell, we're going to talk about that later. There are 2 electrodes. Where reduction is taking place is cathode, reduction takes place in cathode, oxidation takes place in the anode. The anode is where zinc is. Reduction is where the electrode is copper. Copper is deposited from the solution into the copper electrode. Zinc electrode going to dissolve into solution as zinc 2 plus. So if you separate these two solutions through a Sol bridge, we're going to look into this. Sol bridge is a small connector between two solutions. You're going to create a galvanic cell. A galvanic cell is a device that converts the energy released in a spontaneous chemical reaction into electrical energy. This takes place spontaneously. That's what the way it is. While this redox reaction taking place, the transfer of electron from one substance to another take place. The electrons are passed from zinc anode to the copper cathode. Why I am saying copper is cathode, where reduction is made. Zinc is the electrode, where oxidation. We're going to look into that. I'm just getting a head start here. The electron transfer process involves 2 charges, 2 electrons here, copper 2 plus to copper. And the copper is reduced by picking up 2 electrons. And zinc is oxidized, losing 2 electrons produce zinc 2 plus. Now I'm going to show you this change in the topic. Statue of Liberty, when they made the statue, it was copper. Copper has a nice reddish brown color. When you polish copper, it's as in the picture. But with the oxygen in the air, copper get oxidized to copper 2+, and oxygen get oxidized to reduced to oxide ion, gain electron. So there's a redox reaction take place between copper and oxygen. So application, the examples of redox reaction. Copper is oxidized, oxygen is reduced to oxide. Now there are half reaction. We already saw galvanic cell have half reactions. Copper 2+ to copper, zinc, neutral zinc, zinc 0 to zinc 2+, loss of 2 electrons, oxidation. Half reaction is what takes place in each half reactions. The electrodes, 2 electrodes separated by salt bridge. Each process of oxidation is called reduction oxidation, is expressed as a half reaction. One thing you can say is any redox reaction have half reaction. You can create any redox reaction to create a battery. But batteries are made from commonly available chemicals and most efficient one. Even though there's possibility of making millions of batteries from different reactions, some of the reactions, redox reactions, are most convenient to produce a galvanic cell. So galvanic cell, as we talk about zinc going into zinc 2+, losing electron oxidation, that's the cathode, that's the anode. Oxidation is anode. Reduction half reaction is, reduction take place in the cathode. Cathode is copper here. Now, overall reaction is when you add half reaction, the electrons has to cancel out. Electrons are transferred to the external wire to produce energy, electrical current, which we can use as a to run a device, bulb, computer, etc. The zincs release 2 electrons in half reaction and produce 2+ ion. Copper accept 2 electrons, which result in 0 charge. Therefore, is oxidation state. The charge on the ion is called oxidation state. Copper has 2+. 2+ becomes 0. Zinc has 2+. Zinc plus 2 is oxidation state, is, we call it oxidation state. Charge on the ion. It turns into 0 to +2. Copper +2 to 0. Net 2 electrons are transferred. The overall reaction does not include electrons. They must cancel when adding up the half reaction. Electrons are just transferred. So they are neither created nor destroyed. So therefore, electron must be cancelled when adding half reactions. So let's look at half reaction and tell whether they're oxidation or reduction. Aluminum 3+ gains 3 electrons, become aluminum 0. Metallic compound atoms have 0 oxidation state, 0 charge. Therefore, aluminum 3+ reduced to gain of 3 electrons, produce aluminum. That's a reduction half reaction. Zinc going into zinc 2 plus and 2 electron. Is it a reduction or oxidation? It's an oxidation because zinc loses. So if you find electrons on the right side, that is an oxidation. If you find electron on the half reaction on the right side, product side, aluminum plus 3 electrons, that's a reduction. So this is reduction. Manganese 7 plus, 3 electrons go to manganese 4 plus. Water also breaks up into oxygen, releasing 4 electrons. So that was when water take place. Other half reaction is iron. Iron and water produce iron oxide. So this is the half of the oxidation half reaction. Hydrogen also can accept gain 2 electrons. That's reduced to hydrogen. Protons are reduced. So you can tell which ones are half reactions are oxidation and which one are reduction. There are ways to remember this. Use mnemonics. Oxidation is loss. Oil, OIL. Oxidation is reduction is gain. Oil rig. Oil rig summarized mnemonically. Oxidation is losing. Reduction is gaining electrons. So that way you can remember. There are so many mnemonics. Loss of electron is oxygen, gain of electron is reduction. That mnemonics is Leo, L-E-O, Leo. There's a lion called Leo, according to this mnemonics. Leo the lion, G. G means gain of electrons. Now, how many of you got the idea that loss of electrons is oxidation, gain of electron is reduction? Okay. We're going to look into more details of galvanic cells. There's a battery. Positive charge is the cathode. What did I say? Cathode reduction takes place. Negative charge is anode. Anode is where oxidation takes place. Where oxidation takes place, negative charge, anode. Electrons are passed through a current. Current passed through the arrows indicate it passed through a wire, light up a bulb. There's a switch. If you break it up, then circuit is open. So from anode to cathode, electron pass through. Anode to cathode. Normally in a battery, you call this current. Current is opposite of electron flow. We didn't know about the electrons before. We thought positive charge travels through the wire to the negative charge. Now we know exactly current is opposite of electron flow, current flow. So let's look at that. The transfer of electron to an external electric circuit produces electricity. Moving electrons have potential. The current is, it follows the Ohm's law, V is equal to IR. V is equal to IR. Potential is resistance to the circuit multiplied by current. To enable this transfer, electrodes are placed in the cell as site of chemical reaction. There are two electrodes, positively charged and negatively charged. I told positively charged is cathode, negatively charged is anode. The difference in electrochemical potential between two electrodes is the voltage. So different chemical reactions produce this electrode potential. The redox reaction, different redox reactions have different potentials. Therefore, its specific voltage produced by a battery depend on the chemicals used in the redox reaction. They are measured in volts, electrical potential. Now let's look at the Ohm's law. Ohm's law relates electric potential V is equal to current going through the wire and the resistance. Now when you see the red guy is the resistance. It kind of a red figure here. Volts is the green guy. Blue guy, volts is the yellow guy. Current is the green guy. Green guy passes to the wire. That's the current. So voltage is the one that pushes it through from one end to the other. The red guy, the resistance, controls it. Therefore, this relationship. Higher the electrode potential, higher the resistance being same, higher the current. V and I being same. If you increase the R, if you have constant potential, if you increase the R, current going to be reduced. That's the Ohm's law. So we use that in electricity, dealing with electric currents problems. This is V is equal to II is called the Ohm's law. Now different oxidation redox reactions have different metal oxidation state participating in chemical redox reactions. If you look at the periodic table, these are the groups, 18 groups. Group 1A, common oxidation state, charge of the ion is the same as oxidation state is positive 1. Group 2 is positive 2. Group 3, 14, 15, 16, 17, 18 on the right side. Some of them have multiple charges. If you look at 13, they have only fixed charges, +3 and +1, +4, -4. The tin could have +4, -4. So there are variable charges in group 13, 14, 15. Transition metal always use more than one charge. Therefore, redox reaction involves change in the oxidation state by gaining or loss of electrons. So this diagram provides you with different available possible oxidation states for different metals. Electron transfer in battery takes place within its electrodes. Electrodes are the cathode and anode. Electrical conductors that save, electrodes are the electrical conductors that saves as the site for electron for the redox chemical reaction. Anode is where oxidation takes place. Remember, first time I talked about zinc going into zinc 2+ is the anode of the galvanic cell, where zinc 0 going to zinc 2 plus is oxidation. So anode is where the oxidation takes place. Cathode is where the reduction takes place. So pretty much if you got these ideas about galvanic cell, what is the cathode, what is the anode, we have electron flow from anode to cathode, current flow from cathode to anode, etc. You pretty much got the basic idea about the galvanic cell. Depending on their group number, elements have different oxidation state, different charges. So you can look into this and how a metal oxidation state change from like iron 3 plus to 2 plus. 1 electron is gain, 3 plus to going to 2 plus. How many electrons lose or gain depend on the change in the oxidation state. So basically batteries are galvanic cells. They have specific redox reaction. We're going to talk about different kind of batteries, what kind of a chemicals are used in the battery, whether they are rechargeable, whether they are just primary, they couldn't be recharged. A battery is a system for the direct conversion of chemical energy to electrical energy. When the redox reaction takes place, current is passed from the cathode to anode, or electron flow from the anode to cathode. So you have to isolate the cathode and anode. Normally, if you short circuit, the battery will go dead faster, release the energy. Batteries are found everywhere in today's society because they are convenient, transportable. They are used in many applications where direct electricity couldn't be used. There are many places where we couldn't use direct in-grid electricity. So if you had to start a car in the middle of somewhere, you need a battery, lead acid battery. The batteries shown here are called galvanic cell. Electrolytic cell is when you are recharging a battery, it produces the chemicals. You have to use an electric current, opposite direction to the charging, and discharging is other way. A series of galvanic cells that are wired together constitute a battery. For example, lead battery. How many of you know your car battery's voltage? 12 volts. How do you get 12? There are 6 batteries, lead acid batteries, combined in a series. Series means one after the other. The voltage add up to 12. 2 times 6 is 12. That's how you get 12. So 12 volts produced by lead car battery. Now let's look at the galvanic cell in more detail. The first reaction we could talk about zinc going into zinc 2 plus and copper going into copper 2 plus from the solution, depositing on the copper cathode. Copper cathode is on the right. Normally, when you're writing a galvanic cell, we follow these conventions. Cathode are shown on the right. Cathode. It's a copper, is the cathode. Zinc is shown in the left side, anode. The the pathway that's called Sol bridge is a solution of sodium chloride to keep the electrical connectivity between two solutions. They prevent direct passage of copper into other side of the galvanic cell. Galvanic cell is a setup that separates out two electrodes, and electrons are transferred from the cathode, from anode. Zinc is the anode. Electrons are produced in the zinc by zinc dissolving into the solution on the bubble here on the left side. Zinc goes out of the electrode, leave out an electron, two electrons. Those two electrons pass through the wire, and it shows using a voltmeter. Electrode potential of this galvanic cell is 1.10. Always, if you make a galvanic cell using zinc, copper electrodes, and the nitrate is the common ion for the two solutions that are deep in where the electrode are deep and connected by a Sol bridge, that is a kind of a galvanic cell. So copper is deposited from the solution onto the cathode surface. Therefore, two electrons are extracted from the copper to make copper 2 plus 2 copper. So reduction is taking place. Cathode is where reduction. So did you understand basic idea about how a galvanic cell works? You can create up any electrode situation, cathode and anode, and draw a galvanic cell for any chemical reaction. It could be a fuel cell, lead acid battery, different types of batteries. So it's the same. Each one has cathode and an anode. Let's look into different galvanic cell. The galvanic cell we talked about was copper, zinc, electrodes dipped in copper sulfate, copper nitrate, or copper zinc nitrate solution. Some common galvanic cells. Let's look at the list. Nickel cadmium battery. These are rechargeable batteries we use in toys, portable electronic devices, digital cameras, power tools. Any rechargeable battery that I use in my night lamp could be recharged. This specific nickel cadmium battery has nickel oxide and cadmium. I'm going to show the details. Specific to nickel and cadmium, voltage is 1.25. Then in hybrid cars, you use nickel metal and metal hydride, nickel metal hydride, metal hydride. The minimum voltage is 1.25. Rechargeable, yes. They are more powerful than nickel cadmium batteries. So in a Prius vehicle, there are so many cells that are connected in series. There's a battery pack that creates a potential to run a motor that drives the car when batteries charge. As the car runs on the battery gets discharged. So then the gasoline kick in. And when the gasoline is powering car, the nickel cadmium battery nickel metal hydride battery charges the get charge. So then this cycle, charging, discharging, and car is running basically on battery and the combination of gasoline. So it's more fuel efficient. Now, this is a rechargeable battery used in hybrid vehicles. Alkaline batteries, most common. Alkaline battery is, I used to have a lot of alkaline batteries. 1.5. It is mainly zinc and the carbon, manganese dioxide. We're going to look into that, what manganese dioxide and zinc is the chemicals. They are not rechargeable. They use hydroxides. These are used in flashlight, calculators, video, audio devices, toys. Lithium battery, primary is non-rechargeable. Primary lithium batteries are used in LED lightings, smoke alarms, wristwatches. There are small batteries in calculators, vehicle remotes, key fobs. They are not rechargeable. You buy it in the Walmart and put in your watches, key fobs. And the fourth one is lead acid battery. It's 2.1 voltage. I told you about that. There are 6 batteries connected in a car battery, 6 times to produce 12 volts. Automobile, starting, lighting, and ignition. All these are functions of automobiles, providing power to start the engine, lighting. Then the alternator, while car is running, recharge the battery. So it's a rechargeable battery. Now the other part is lithium polymer batteries. These are the latest types of batteries found in laptops, computers, cell phones, portable electronic devices, and power tools. So they are rechargeable. 20 volts, 15 volts. Power tools use lithium-ion batteries. Lawnmowers, blowers, etc. So how many types of batteries we talked about? Is 6 types of batteries. If somebody asks you, what is the chemicals in a nickel metal hydride battery, nickel and metal hydrides? Nickel cadmium batteries, nickel oxide and cadmium. Lithium batteries, lithium hydroxide. Alkaline batteries, manganese dioxide and zinc. Lithium-ion batteries, lithium ions and polymers. Lead acid batteries, lead and lead dioxide. So we're going to look into these again. The voltage of a battery is determined by the chemical makeup, not of the size of the battery. All the batteries have same voltage, but the bigger the battery, more capacity it has. So for example, flashlights use D batteries or A batteries, AAA batteries. AAA is the bigger one, I guess. A batteries are small one. Alkaline batteries. Small is AAA. Large is D batteries. They produce same voltage because the chemical reaction is same. but they have different sizes, have greater capacity. Larger the cell is, larger the capacity. They can sustain the flow of electrons longer since they contain more material. So it depends on the application. So for example, for a small calculator, you may not need a battery. Now, nice thing about calculators are now they are based on solar cells. So you don't need a battery. But we used to have batteries in calculators. No longer we don't. Primary batteries are the ones that are not non-rechargeable. Their chemical reactions are only going one way. They cannot be recharged. It depends on some chemical redox reactions are not reversible or equilibrium. Non-equilibrium reactions, which are reactants going to products in a redox reaction, are primary only one way. Secondary is rechargeable, able to run redox reaction either way. Drawing the charging, discharging, charging is passing the electrical current to produce the chemicals for the to renew the voltage of the battery. Okay, let's look at the alkaline battery. Did I say MnO2? There's MnO2, manganese dioxide, we call it manganese oxide 4, manganese 4 oxide. That's a paste, purple color. Now, with that, KOH, alkaline is KOH. Zinc coating of the battery outside is the cathode, anode, where the oxidation takes place. Zinc dissolves, producing zinc plus. Manganese dioxide goes into manganese dioxide is the cathode. Cathode is where reduction takes place. Manganese 4 oxide get reduced. Let's look at this. The carbon electrode is not participating in the reaction. It is just the term device to the electrode to transfer electrons. So manganese graphite rod is the black one. Manganese dioxide is the pink or red-brown around the carbon rod. KOH paste and zinc. KOH paste is purple, then the zinc. The reactions take place in anode. Did I say zinc is the anode? Zinc goes to zinc 2 plus with the alkaline OH, KOH. So zinc hydroxide is produced. That's the oxidation. Anode where the oxidation. In alkaline battery, anodes is the where zinc, where oxidation takes place. Cathode is the manganese dioxide. Didn't I say manganese dioxide, that red-brown around the carbon? So it gain electrons, go to manganese, manganese 3 oxide. Manganese is 3. Manganese 4 goes to MnO2, manganese oxidation state is 4. Mn2O3, manganese is 3 plus. 2 plus goes to 3 plus. 2 of manganese dioxide produce 2 electrons. So charge is balanced, 2 electrons from the oxidation half reaction, reduction half reaction 2. So the total overall zinc is reacting with manganese dioxide and water is there. Zinc hydroxide is produced, manganese 3 oxide is produced. So this is not a rechargeable, this is a primary. So KOH batteries, KOH in alkaline batteries are more powerful, will produce a lot of, has more capacity than non-alkaline batteries. These are the rechargeable batteries. Nickel cadmium. If you look at the nickel cadmium means nickel oxide and the cadmium anode. Anode is cadmium where oxidation takes place. They also have KOH paste. They are alkaline medium, produce strong currents. So nickel oxide is there. So when you discharge the battery, anode is cadmium. Cadmium goes to cadmium 2+, cadmium hydroxide. Cathode goes nickel oxide, goes gain electrons, reduction, goes to nickel hydroxide. So this is the complete, the anode half reaction, cathode half reaction. These are, when you add up these half reactions, you get cadmium with 2 nickel oxide, hydroxide, solid with 2 order molecules, to cadmium hydroxide and nickel hydroxide. This is the discharge. If you charge it using your charger hooked up to wall, outlet wall, so they reproduce cadmium and nickel oxide, so you can reuse. This is a secondary rechargeable battery. So cadmium, nickel cadmium battery is very common. For charging, above reaction proceeds in the opposite direction. During the charging, opposite reaction takes place. Discharge means when you draw electrical current. Now I'm going to talk about this and stop the class. Lead acid storage battery is used in cars. There are 6 batteries in series hooked up to each other. Therefore, voltage is 6. 6 times 2 is 12. The electrolyte is sulfuric acid, very dangerous. Lead oxide is and lead dioxide is used in as 2 electrodes. Lead acid batteries are the workhorse of today's rechargeable battery, automobile, motor that power cars. We also use lead batteries, lead acid batteries to store solar energy. So therefore it's become a workhorse. So some solar power grids use lithium ion batteries now. They are a little expensive. The overall chemical reaction, cathode reaction and anode reaction together. Lead is the cathode. Lead oxide is the anode. So lead oxide is that positive red cathode is lead. So anode is lead oxide. So they are connected in series, 6 of them. You can recharge this reaction. from discharging is drawing electric current from the battery. After that, you can recharge from reactants to products, passing a current by the alternator. Alternator reverses. Once the car is started, alternator automatically produce more than 12 voltage in opposite direction. So only when the car battery is used is when you are cranking the engine, starting, turning light while car is not working. While car is running, alternator keep it recharged. I'm going to talk about other aspect of energy density of batteries, supercapacitors, capacitors, and fuel cells in the next class. All right. Do you have any questions?